Good morning, grade 8 learners. Welcome to Valenzuela live stream. For today's topic, we will be focusing on the module about answered yes, it has force on it, or it has force acting on that object, then you are correct. So why? That is because of the gravity. Right, so there are so many types of forces, but we will categorize them into two. The first is the contact forces, and then the second one is what we call the non-contact forces. What do we mean by contact forces? When we say contact forces, it is an interaction between objects that touch, that has contact with each other. While non-contact forces, it attracts or repel even at a distance. So meaning to say there is no contact with each other. Now, here are some examples of contact and non-contact forces. The first one under the contact forces is applied force. Meaning to say, if we push or pull off an object, we are applying force on it. Next one is the spring force. As you've seen, the spring. So there is a contact within the object. The third one is frictional force. So it causes the object to stop. And then, the last under the contact forces is a normal force. Like the table, on the example a while ago, the force that is exerted by the table. Now, let us now proceed to the non-contact forces. So, for non-contact forces, we have here, the first one, magnetic force. The second one, electric force. And then the last one is the gravitational force. As you've noticed, here on non-contact forces, they are not having a contact. That's why it is called as non-contact. Right, so, now, the question is, what if we replace the of an object, the harder it is to change the state of the body, the harder it is to be moved. We can use the buoyancy and flotation topic, but this topic is on your grade 10. So we'll focus on the second one, which is law of inertia. Later, we will be having an example of it. And then the last one is biology. So in biology, literally, so you just need to simply wait for at least
23 days
for the egg to be hatched. So that is the biological way. Now, for us to be able to better understand this example, let us now proceed to our experimentation table. As you've seen here, I have 2 eggs on my hand, so the left and the right. So, we will try to see which one is boiled or not. So, I'll try the right one first. So, for us to be able to determine if it is raw or boiled, we need to spin it and look on its motion. Be careful not to be dropped on the table. So what can you notice on its motion? Is it too fast or too slow? Good. It's too slow. Now, on my left hand, I will now try to spin the other egg and try to observe what will happen. Is it too fast or too slow? Good. It is too fast. So meaning to say that this one is too fast and the other one is too slow. So the egg that spins faster, this one is the boiled one. And then the other one, which spins slower, that is the raw one. Now, why do I say so? Now, applying the law of inertia, we said that inertia is a tendency of an object not to be moved, or an force applied is only 30 Newton. But what if passenger, then it accelerates slower or it has slow acceleration. Okay, if the jeep has less passenger, it could accelerate higher. Okay, so that's the thing. And also, it could be also presented in a mathematical formula. So we have here, the acceleration is equal to, acceleration is inversely, because there is a sign of division. So it is inverse, they are not equal. So acceleration is inversely proportional to the mass of an object. So we need to put 1 to show the inversely proportion. Now, if we will combine those two formulas, this formula is for the acceleration that is directly proportional to the force, and the other formula is the acceleration which is inversely proportional to the mass. If we will combine it with each other, we could come up with one formula, which is this one. The acceleration is equal to the force of an object, but it is inversely proportional to the mass of the object. Did you get it? Okay, so now there are so many easy ways for us to be able to know or to remember this formula. Like for example, the family. I called it as the family formula. The family, why? Because we have the family. We have the father, we have the mother, and we have the anak. Alright, so how does it work? If force is missing, then we should multiply acceleration with the mass to get the force. If acceleration is missing, we should divide force to the mass of an object. And the last one, if mass is missing, we should divide force into the acceleration of an object. So always remember that. Now, also, do you remember Red a while ago? Red said that 1 Newton is equal to 1 kilogram times meter per second squared. So, they are the same. If you will analyze this formula, 1 Newton here is for the force. And then, for kilogram, it is the mass of an object. And then, for the acceleration, the meter or the unit is meter per second squared. Take note that the value of gravity here on Earth is 9.8 meter per second squared. That is the acceleration due to gravity. In case I drop this pointer or clicker on the floor, aside from I will pay for it, so it will also drop 9.8 meter per second squared due to gravity. If you have any questions, you can write it on the comment section below. Now, before we end this discussion, I wanted you to remember two things to remember. So the first one is about inertia. So the two things that you need to remember in inertia is it is an object at rest and object in motion. An object at rest will remain at rest. It will not be moved. Not unless if there is an external unbalanced force on it. Now, the second one is it is an object in motion. An object in motion will continue to move regardless what happened. But it will stop moving not because the force is up. No. It will stop moving because there is a frictional force that stops it. Next. On law of acceleration, also, we have two things to remember. The first one is it is directly proportional to the force, and then the second one is it is inversely proportional to the mass. Right? So here, the first one, the acceleration is equal to the force, and then the second one is acceleration is inversely proportional to the mass. Alright, so at this point, for next week, I have a homework for you to study. So the question is, what are the two things or two important things to remember in Newton's third law of motion? Now, do you have any questions? You can type it on the comment section below. So I hope that this day has a full of learning. So that will be all, and see you next week.